Hello guys, welcome back to my YouTube channel. As you know, I am Akshata Patil from Sri Venkateswara College of Engineering, Bangalore, and today's subject is mathematics and the topic is applications to find area and volume by double integration. So we will start our topic applications to find area and volume by double integrals. Let's start with application of a double integrals. To find the area of a curve y is equals to f of x bounded by the x-axis and the extreme ordinates x is equals to a and x is equals to b, which is given by integration of f of x from a to b. So next we will discuss applications formula for area and volume. First one is double integration of dx into dy. This is the area of the region R in the Cartesian form. Then the next one, double integration of r square into dr into d theta is equals to area of the region R in the polar form. Then double integration of 2 pi r sin theta into dr into d theta. This is the volume of a solid obtained by the revolution of a curve enclosing an area A about the initial line in the polar form. These are the formula for area and volume. Here we will discuss some problems on area and volume. So first we will discuss the problem on area, that is to find the area of an ellipse x square by a square plus y square by b square is equals to 1 by double integration. So we know the formula area A is equals to double integration dx into dy. So here we will consider A is equals to 4a because of an ellipse. Then we have to take the limit for y and x. So for y, the limits are 0 to b by a root a square minus x square, and for x 0 to a. So first we have to do integration with respect to y and then we have to do integration with respect to x. So after integrating with respect to y, we have to substitute the limits for y. Then we will get area A is equals to 4 integration of b by a root a square minus x square into dx from 0 to a. So next we will integrate with respect to x. Then we will get a is equals to 4b by a into x root a square minus x square divided by 2 plus a square by 2 into sine inverse of x by a. Then we have to substitute the limits, that is from 0 to a. Then we will get 4b by a in bracket 0 plus a square by 2 into sine inverse of 1 minus sine inverse of 0. So we will get 4b by a into a square by 2 into pi by 2. Here this a and this a will get cancelled and 4 and this 2 and this 2 will get cancelled. So we will get pi ab. Thus the required area A is equals to pi ab square units. So next we will discuss problem on volume, that is to find the volume generated by the revolution of the cardioid r is equals to a into 1 plus cos theta about the initial line. So we know the formula for volume of the solid of a revolution in polars, that is V is equals to double integration of 2 pi r square into sine theta into dr into d theta. So here we have to consider the limits for r and theta. So we will consider the limits for r, that is 0 to a into 1 plus cos theta, and for theta that is from 0 to pi. So first we will integrate with respect to r, then we will get 2 pi into r cube by 3. So here we have to substitute the limits, that is from 0 to a into 1 plus cos theta. Then we will get 2 pi by 3 integration of a cube into 1 plus cos theta whole cube sin theta into d theta from 0 to pi. So next we have to integrate with respect to theta. So here we have to put 1 plus cos theta is equals to t. Then we have to differentiate with respect to theta. Then we will get minus sin theta into d theta is equals to dt. Here we have to substitute the limit. If we substitute theta is equals to 0, we will get t is equals to 2. And if we substitute theta is equals to pi, then we will get t is equals to 0. So we will get v is equals to 2 pi e cube by 3 integration of t cube into minus dt from 2 to 0. Then here we will exchange the limits. Then we will get 2 pi a cube by 3 integration of t cube into dt, and the limits are from 0 to 2. So we will integrate with respect to t. We will get 2 pi e cube by 3 into t power 4 by 4, and the limits from 0 to 2. Then we have to substitute the limits. We will get 8 pi e cube by 3. Thus the required volume V is equals to 8 pi a cube by 3 cubic units. Next we will discuss application of integration. Double integrals are very useful for finding the area of a region bounded by curves of a function. We can use the integral to get the area between x-axis and y-axis and a function. We can also get the volume of the figure by rotating the figure around either one of the axes. We can use the integrals to find the area between curves. Then we can use the integrals to find the volumes of a solids by the washer method. Then we can find the volumes of a solid by cross-section method. Then we can find the volumes of a solids by the shell method, and also we can find the volumes of a solid by the disk method. These are the application of a integration. Thank you everyone for watching my video. Please like, share and subscribe.